Okay, so welcome to the second set of questions. That would be questions 11 through 20. So let's get into the questions right away. So the first one right here is, what is the least number of circles that can be removed from the following figure so that none of the circles intersect any other circle? Now again, it's an optimization problem in the sense that you'll have to think of removing stuff and then making the optimal value. Okay, so let's look at this. And if you remove, I mean, think of removing the biggest, not the biggest, think of removing the circle that intersect most other circles, and that would be this circle. Okay. And if you remove that, you can see still it is not non-intersecting, still things are intersecting, but you can see most of the circles, okay, at least one of the circles now become unentangled. Okay. Now what I think the next one to remove would be this circle. And you can see once this is removed, it will be totally unentangled. Okay, so it's immediately the answer is 2 circles. Okay, the answer 1 is not there. That also indicates that we have the correct answer. 12. How many 4-digit numbers are there such that the hundreds digit is 6 more than the ones digit? So let's look at what is this one of those possible numbers. So let's say 2000, I don't know, 50 something. Hundreds digit is 6 more than. So if this is 1, this should be 7. Okay. And there is no restriction to this. You can have 1, 2, 3, 4, 5, 6, 7, 8, 9 choices here. And there is no restriction on this digit. And also you have 0 because you can have 0 in the middle. So 0, 1, 2, up to 9. So 10 choices. How many choices these have? Well, you can have either 1 and 7. Of course, 0 and 6. 2 and 8, 3 and 9, and that's all, because if you have 4, must have 10, but it is not a digit. So there are only 4 choices for this. For each of these 4 choices, there will be 10 choices for the tens digit and 9 choices for the 1000th digit. So you'll have 360. Okay, let's move on to the question number 13. If in the following figure, the areas enclosed by the egg-shaped circles represent different number types, then which of the following gives you the number types that can be accurately represented by the figure? So this is a question that makes you think a little. Okay, first of all, if any multiples, now these are integers. Okay, so it can have 0, it can have negative numbers, different number types. So again, multiples of 4, these are like -4, 0, 4, 8, 12, and so on. So it goes both sides. So you can see 0 is there. So all these numbers, whenever it says multiples, you have 0, which means if 0 is in here, 0 must be in here. So 0 must be in here. And this indicates 0 is not there. So it would be the only number system that doesn't have 0 in it as a small island by itself would be prime numbers. So just that gives you the hint that this should be prime numbers, and none of these are going to be multiples. Therefore, the correct answer is multiples of 4, multiples of 12, prime numbers and numbers. Question number 14. The following 10 by 10 grids consist of 100 small rectangles, okay, and then side lengths 3 centimeters and 4 centimeters. Okay, so which means you have 30 centimeters this side and 40 centimeters that side. Okay, so you can go, an ant can go either vertically or horizontal. Okay, so that would be going at 70 centimeters in total. However, if the ant so wishes, it can go like this horizontally, and then maybe 3 vertically, and then 2 horizontally, and then maybe vertically 4, 2 horizontally, like that. No matter how does the ant go, if you look at from this direction, it has gone 30 vertically. And if you look at from this direction, it has gone 40 horizontally. So no matter how it goes, as long as it doesn't go through the diagonals, it will always be 70 centimeters. So it says horizontally to the right or vertically up. That's the only way the ant can move. The distance ant crawls by crawling vertically up to C and then horizontally is longer than the distance, so that immediately becomes false. And finally, if the ant crawls along the diagonal, so if you have, let's think about a small box here. You have 4 centimeters and 3 centimeters. However, if you walk along the diagonal, that would be 5 centimeters. So here, this way would be 7 centimeters and this way would be 5 centimeters. So you will shorten your length. So it will reach the distance in less than 70 centimeters. That's correct. So that's 2 and 3 on. Question number 15. In the scales, the 5 balls labeled A, B, C, D, and E weigh 20, 100, 100, 100, and 120 grams, not necessarily in the same order. The question is, which ball weighs 20 grams? Now let's see how to arrive at the solution the fastest, okay, without even worrying about other balls. Now, first of all, I will select this way, okay, that scale, because it gives me more information because there's an equality. Okay, here it is an inequality, which means there might be some information that I might not know, not get from here. This has more information in it. And so how do you balance something? So you have 20, 100, 100, 100, 120. So if you pair these up and then take these three, you should have here 20, 100, 100. And here it would be 120, 100. Okay, so the choices for 20 ball are either C, E, or B. And whatever that 20 ball is, if you put in this scale with anything else, you will get a lower weight. And you can see that C is in here. So my hunch is this is the 20 ball. Okay, can that happen? So let's see. Let's say A is the next lightest one, 100. And let's put some, okay, so these both must be 100 and 100 if that's the 20 ball. And you can see this is 200 and this is either 120 or 140. In either case, this is heavier. And C being 20 actually tells you that this is the one possible answer. And because it's a well-posed question, it is the only possible answer. So the answer is C. Okay. Let's go to the question number 16. Sarat, Abdul, Meena, Kamala, and Susan have different numbers of marbles totaling 125. And it's important that it should be different number of marbles. So this is not a choice. Even though it adds up to 125, you don't have different number of marbles. It is the same number of marbles here. So if I want to make this smaller, I will use 1 here because they have marbles, so you can't have 0. And then 2 is the next possible number, which is different from 1. 3 is the next possible number, and 4 is the next possible number. So you should have a total of 10 marbles with 4 of them, and the other guy can have 115 of them. So that is the greatest number of marbles a person can have in these conditions. Let us move to question number 17. We say that a 3-digit number is balanced if the middle digit is the arithmetic mean of the other 2 digits. Okay, so look at the middle digit. So what are the choices for the middle digit? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and it's a 3-digit number. Okay, and also you can have 0. Now, if it's 0, the middle digit is the arithmetic mean of the other 2 digits. So what are the, okay, so let's say this guy right here, 1. If it is 1, okay, if the middle number is 1, and then you have, let's say, A and B on the sides, then A plus B over 2 should be 1. So A plus B should be an even number. Okay, so what are the possible choices? Well, you can have, what are the possible choices for the other numbers that you can have? Well, you can have 1, 3, 5. Okay, so 1 plus 3 over 2, that would be 2. Sorry. Here, balance. If the Okay, so let's start, restart the recording. I really got distracted, and let's look at this question right here. So a 3-digit number is balanced if the middle digit is the arithmetic mean of the other 2 digits. So I think what you can see here is, let's say you have a number A, B, C. Okay, and then the idea is A plus C over 2 is equal to B, or A plus C is equal to 2B. And what kind of numbers are these? Well, of course, you can understand that if A is not 0, go down this way. Okay, and then as you can go as long as you hit either 9 or 0. And all these numbers you will have are balanced numbers. So let's see how many balanced numbers are there for each digit. So for 1, you can have, of course, 1, 1 by this reasoning. And then you can go up 2, and then you hit 0, and that's all. Okay, so you will have 2 balanced numbers here. 2, how many of them are there? Well, you can have 2, 2. Okay, this will mean the balanced number is 2, 2, 2. So this is the first digit, second digit, and the third. And then you can go up, so you can go 3, 1, and then you can go 4, 0. And the another thing that you have to keep in mind is if A, B, C is balanced, and then let's say A not equal 0 or C not equal 0, then CBA is also balanced. So you will get, if you don't have a pair, you will get always 2 balanced numbers. So in that case, you will have 1, 3 pair. Okay, and you don't get a pair from here, you get a pair, you don't get a pair. So in total, you have 4 balanced numbers. 3, let's look at it, 3, 3, and then go up 4, 2, 2, 4, 2 balanced numbers. 5, 1, 1, 5, two balanced numbers, and then 6, 0. So you have 6 balanced numbers. You see the pattern. And then the next one, I'm thinking of 8 balanced numbers. So 4, 4, um, 5, 3, 3, 5, 6, 2, 2, 6, 7, 1, 1, 7, 8, 0. So you have 8 balanced numbers. Now, when it hits 5, things become different, slightly different, because you will hit 9 before you hit 0. So let's see what happens. Okay. So you have 5, 5, 6, 4, 4, 6, 7, 3, 3, 7, 8, 2, 2, 8, 9, 1, 1, 9. And then you don't have 10, 0 because that's not a number. So you will not hit that upper point. You stop there once you hit 9. Okay. So now you will have 1, 2, 3, 4 pairs and 9 numbers. And 6. Okay. Now you see all the time a pair vanishes. Okay. 6, 6. And then 7. You go up, go down. 7, 5, 5, 7, 8, 4, 4, 8, 9, 3, 3, 9, and you stop because you can't hit 0. So again, 3 pairs and 1, so you get 7. And 7, 7, I'm not going to see it. You can see the pattern. You can have 7, 7, that's 1, and then 2 pairs. So you get 5 numbers. With 8, you can get 8, 8, and 1 pair, and that's 3 numbers. With 9, you can get 9, 9 only, and that's 1 number. So you have 1, 3, 5, 7, 9, 8, 6, 4, 2, or just 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's 45 numbers altogether. I'm very sure that there might be an easier way to solve this, but it's actually a cool problem that stumped me for a little bit. Okay, let me go to question number 18, which also stumped me when I did it for the first time. The following two intersecting rectangles divide the space inside the rectangle into 3 regions. What is the largest number of regions inside one or both rectangles one can create using 2 intersecting rectangles? Okay, so for example, if you do like this, you will have 1, 2, 3, 4, 5 regions. But if the rectangles are more square-like, and if you intersect it like this, you can get 1, 2, 3, 4, 5, 6, 7, 8, 9 regions. And that would be the largest number, and you can see 9 is the largest number here. Let's move on to question number 19. Okay, you have a tic-tac-toe question. And the one uses zeros and other one uses x's, crosses x's and o's. Okay, whoever get 3 x's and or 3 o's in a row, so they get in turns in a column or a diagonal bins. If the game ends in a draw, what is the total number of moves played by the 2 players? Well, of course, if the game ends in a draw, then all these 9 should be filled in. Otherwise, you can't say it's a draw. So, I mean, without looking at which player starts first, all 9 squares should be filled in. So it should be 9 squares. If you know who is playing, you can end in, if the game ends in draw, you should be able to say it in about 8 times, 8 squares. But if you don't know who's doing it, who's going first, then you have to say 9. And the last question for this session is again a tic-tac-toe question. And well, I think, I mean, if you guys are inclined mathematically, you really see that, okay, if I do that, you cannot defend because either you will have to put 0 here or here, but not both. So if you put 0 in one of them, I can put X in the other and win. Okay, so you can win by putting an X on the second column, but also you can win by putting an X in the middle column. If you put an X in the middle column, then you again have to defend this position or this position. You can only defend one position, which means I can draw the triangle in the other position. Okay. Right. So actually, this small mistake there on my side, like we'll have to either defend this position or this position. But again, you will put your X in the other one. So I think I hope you enjoyed the pattern seeking and gaming behavior in that set of questions. In the next one, I'll see you with the questions 21 to 30.